out. It was page 67, is that correct?
Yeah.
Okay. Let's start going through, talking about how these work. Problem 1 and 2. Problem 1, we have 8, 4, 2, 4, 8, negative 4, negative 2, 0, 2, and 4. Number 2, we have 0, 2, 4, 6, 8, and 3, 7, 11, 15, and 19. Okay. Hey, Steve, could you flip the lights down for me, please? You get a chance. Thanks, Bob. All right, the top is the input, the bottom is the output. Input is the x, output is the y, input is the domain, range is the y or the output. So we're looking if the input or the domain repeats, they want us to say if the relation is a function. So a relation, if you remember, is just ordered pairs. And then a special one could be called a function only if the domain didn't repeat. So this is no, and then explain domain, which is also called input, repeats. And that's a legitimate answer. Okay. Problem number 2, top is input, bottom is output. So 0, 2, 4, 6, 8. Nothing repeats. So yes, this relation is a function. The domain does not repeat. Okay? That's as simple as we can make it. I don't know any other way to explain it. I'm sorry. Then problem number 3, you have, I don't know, it's kind of like this. I think that's close. So they want to know if this is a function or not. So determine whether the graph represents a function. Explain. What test? Ram, what do you got? Yeah. So if you draw any vertical lines, whoa, not sure how that happened. Any of these vertical lines, if I draw, only touches one of the points. So yes, this is a function, or this is a function. And then you could say that the vertical line passes. Our vertical line test works, or vertical line only touches the graph once, no more than that. But then problem number 4, looks like they have this. And this one, if I drew a vertical line, touch twice, not function, because the vertical line touched twice. Or more, it could be more than twice if it depends upon your scenario. Okay? Alright, so 3 and 4 are done. Number 5 and 6, find the domain under the range of each that are represented. So problem number 5 and problem number 6 we could do on the same. What I would do is just write down the ordered pairs first and then go with the domain and range. So it looks like we have maybe negative 3, 2, and negative 1, 0, maybe, and 0, 3 perhaps. 1, comma 2. 3. Do I have them all? Is that it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So they want to find the domain and the range. So the domain. So a lot of people are like, oh, you always have to put them in order. It's not really that important to put them in order, but you could. Here's your domain, your range is this. Now, sometimes it's not necessary to list the same point multiple times. Okay? So this could be written 2, 0, and 3. You don't have to write the whole thing out. I personally feel it's okay to write the whole thing out. It's just the fireman, battalion chief. I thought it was my mom showing off her new air horn on her car. You never know. So the domain is just all the x values, the range is all the y values. And again, if either of them have any types of repeats, it doesn't have to be written. I think it's fine though. Find the domain and range of the function represented. So these are all functions. So the domain doesn't repeat at all, so it is a function. So that's great. And then problem number 6, it looks like we have these points: -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So this is also a function. So my domain is -2, -1, 0, 1, and 2. And then the range, -2, -1, 0, 1, and 2. So domain and range happen to be the exact same thing. Yeah.
So like, I didn't like list out like the domain and range, like you did at the bottom, but I only did the points.
You only did the what?
So I only did like the relations and the ordered points, or the ordered pairs, and I didn't do like the domain and the ranges you did on the bottom.
You're fine as far as practicing right now, but if you did it on a test or quiz, I'm docking your points. Cool? Giddy up. All right. Problem number 7. Problem number 7. This says the function y equals 7x plus 35. What's a word problem? Oh, this should be fun. Represents the monthly cost, y in dollars. Okay, of a group of X members joining the fitness club. Members joining fitness club. Okay, so this is a linear relationship. Identify the independent and the dependent. Oh. Okay, independent is the x-axis. Dependence the y-axis, always. Okay, not just this week, always. So we have that. So independence x, dependence y. I think we've identified enough of that. I don't know if we have to graph it or not. Your group has enough money for up to 6 members to join the fitness club. Find the domain and range of the function. Your group has enough money for 6 members to join the fitness club. Okay? You have enough money for up to 6 people. So the domain is the x value, which is the independent variable. What can my domain represent? Should I have negative people joining the club? Am I going to count somebody who's missing a limb as a partial person? No. Okay. So if I have enough money for up to 6, what does my domain have to be? Could it be 0? Yeah. Sure. So I could have from 0 all the way up to how many people? 6. And could I have exactly 6 people?
Yes.
Yes. Square bracket both sides. Your group might decide, you know what, we don't like this place anyhow, this fitness center. So our domain is 0 to 6. They have to be whole numbers. You can't have a part of a person. A child doesn't count as less of a person than an adult just because they're smaller. Sweet. You feeling okay? All right, problem number 8. Does anyone know what that shape is on number 8? Oh, did it ask for the range? I'm sorry. I didn't realize it. Oh, shoot, okay. Domain and then the range. Okay, so being I could plug 0 up to 6 in. If I plug 0 in right here, I get 7 times 0, which is 0, and 0 added to 35, which is 35. So again, square bracket. If no one participated, this rec center is automatically getting 35 bucks. And then if I wanted to figure out the top end of my range, or the maximum amount of money that this fitness center would get, I'm going to plug 6 in right here. Okay, so I plug 0 and 6 in. Plug 6 in, I get 7 times 6 is 42. And then I'm going to add 35 to 42. 77. So that's my range. So that's the minimum up to the maximum amount of money that this rec center or fitness club is going to get off of our firm. Does that make sense? Sorry, I didn't mean to skip the range. All right, problem number 8, we have a parabola. Parabolas are squared. Okay. Okay. All right. Problem letter A. What values of x is g at x greater than 9? Is g at x is what direction? X or y? G at x is what direction? I have x here. This has to be what? Y. So we're looking here. And we want when the values are bigger than 9. So you have it right here and here. I haven't really drawn my thing perfect. So, how I'm going to do that? How I am going to approach this is I'm going to kind of interpolate making just kind of like these boxes. This represents a right angle. Okay, so at what values do those both appear to be at 9? You have to kind of look at your graph. Well, it wants to be like a rectangle of some sort. Yeah. 3 and negative 3? That's what I was thinking. But you guys have better eyes than me. Does that look about right? I don't think we'd be mean to y'all and say, well, no, it's 3.1273. So, what x values gives me a value that's bigger? So this graph here, this is continuing up this way forever and ever. This is continuing up this way. It's also continuing up and over, up and over. So this whole region here is larger than 9, and this whole region here is also going to be larger than 9. So how am I going to represent, how far will this way go?
Infinity.
Negative infinity. So I'm coming from negative infinity, and I'm getting up to the value of negative 3, but I'm making it a rounded bracket. Why am I making it a rounded bracket? Yeah, it's not equal to it. So g at x equaling 9, if I plug 3 into our equation, we get exactly 9. So we're not equal to 9. So is this problem done? No. Is there one other region where it's going to give us a value? Our y value is going to be bigger than 9?
Yes.
And so where's that going to start?
Negative round bracket 3 to infinity.
There you go. So this is the answer to letter A, both of these. Okay? Find the value of y that corresponds when x is 1 to 3. Okay, so I'm just trying to write myself. So letter B goes -1 less than or equal to x, which is less than or equal to 3. So originally they told us that this graph, g at x is equal to x squared. So like that's the equation that's graphed. So what values would g at x become if I were to have this limited? Well, I'm going to plug 1 in. 1 squared is 1. Plug 3 in. 3 squared is? Can it be equal to it? Equal, equal. Square bracket, square bracket. So those are the values that you'd get from 1 to 3. Letter C, find the values of y that correspond when x is greater than 2. So x is greater than 2 is here. So we're looking here to here. Okay? Can it be equal, or is it going to be a rounded bracket? Rounded bracket. 2 squared is? And are we going from 2 to 3 or just going greater than 2? Just greater than 2. So this is just going to continue this way. So 4 to infinity. And it's a rounded bracket because we have just greater than 2. Yeah.
How do you get x squared? How do you get that squared?
This?
Yeah.
Look at the original problem. Use the graph g at x equals x squared. And then x squared, the graph looks like the parabola that's drawn. Cool. What is the domain? So a couple things we can do is we can look at our graph. We can also look at this. Can I plug a negative number into x squared and get some number out?
Yes.
Yeah, if I plug like -10 in for x, I get -10 quantity squared, which is -10 times -10, which is 100, so that's way up there. That works. Can I plug 0 in? 0 squared is?
0.
Cool. Can I plug 100 in? 100 times 100 is 10,000. 100 times 100. Okay? Does it look like when I draw my graph I would have to lift my pencil up ever and jump over a point? Nope. So if we wanted to know what our domain was, I can plug anything in and get something out. I'm not going to get some weird term where I'd have like divided by 0. So my domain goes from negative infinity to positive infinity. Again, I don't have to pick my pencil up as I draw it on the graph. I don't have to get any strange things. I don't have a negative under a square root or anything like that. And then what is the range? Letter E, the range. Take a look at our graph. It's continuous, I draw it continuously, but what's the minimum value I'm going to get in the y direction? 0, everyone agree?
Yeah.
So, and it can equal 0, and then it's going to grow straight up, right? So it's going to go up to infinity. So it's a square bracket here because the point 0, 0 exists on our graph. Because if I plug 0 in for x squared, 0 squared is 0, so that works, so square bracket there. And then letter F, pick a new color we haven't used in a while. Ooh, shoot at. Read. Letter F. Where is our graph increasing? Okay, so when I say increasing, if I were to, how do I explain this? If I were to take a straight line, let's take a whole bunch of these. If I were to take a straight line and do this line is decreasing. This line is decreasing. I take this one here. This line's decreasing. This line straight is still decreasing. If I come straight across here, that's 0. But then if I start going this way, it's starting to increase. Okay? If it's increasing, that means that if I were to have found the slope to the line, which I know you guys have in other grades found the slope, but if I were to find the slope is a positive number. It could be a positive number that's a little tiny decimal, a little tiny fraction, but if it's a positive number, it means it's increasing. Okay? So, where is our graph increasing? Look at the x. From here, this way, it's going to be an increasing graph. So where's it starting? 0 and going to infinity. And it's a rounded bracket because right at 0, the slope is actually a horizontal slope, which means it's a 0 slope. A 0 slope is not increasing nor decreasing. When you get to the class called calculus, you're actually going to find that that's a point of inflection, or it's a critical minimum or a critical maximum. That's, when you find the slopes are 0. So, this does tie to later math classes for sure. And I would strongly encourage you all to go through and take calculus. If being there in this class right now, this would be a class you would take in college, which is great. Calculus is one of my favorite math classes. All right, problem number 9. This graph looks a little bit different. This is the graph h at x is equal to what? 2 what? Not 2x squared.
2 to the power of x.
2 to the power of x. Good job. So my exponent is x. Okay? So I have a sneeze that wants to come out, so it's going to be working its way out here in a sec. So this graph kind of looks like this. Okay? So things that are going on with this line is this line is coming down, getting infinitely close to the x-axis. It's never going to touch it. Okay? It's going to just hover right above it, getting closer and closer and closer, which you could say the x-axis is a limit to this line if you wanted to. Now, as far as if I go to the right, the larger number to the right that I plug in, the larger my number is going to be, because if I put like 2 to the 20th power in, that's 2 times itself 20 times, which gets pretty big. Okay? If you double things quick, or if you have something grow exponentially, it goes quickly. So like 2 to the 0 power is 1. So this point right here is actually 1. Okay? 2 to a negative number means that you're making the number a fraction. If you had 2 to the negative 1, that's 1 over 2. 2 to the negative 2 is 1 over 4. 2 to the negative 3 is 1 over 8. And then it goes 1 over 16. So that's where this becomes closer and closer and closer to this. If I go this way, 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. Keeps going. 2 to the fifth, 32, 64, 128. Yeah.
So in this line, what's 2? Is it the domain of the range?
I'm not there yet. The 2 is just the base row. Okay? So, for what value of x is h at x where'd it go? Less than 2? Okay? So where is this less than 2? So that's basically what I'm doing. I'm creating that rectangle. And take a look. It looks like 1. Would that make sense? If I plugged 1 and 2 to the first power is 2. So from here this way, I'm going to be getting less than 2. So I'm going to say that the values from negative infinity all the way up to 1 is 1 square or rounded.
Rounded, not including it.
Yeah, we're not including it. Okay? Letter B, find the values where x is greater than or equal to 3. Okay? So you get 3 here. So if I plug 3 in, this is 2 to the 3rd power. That's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So it's going from 8 all the way to infinity. Is this a square or a rounded bracket? Square. Why? Yeah, it's got the equal sign. Okay. Where does it appear this graph is increasing? So how this is going to work, I'm going to take this, go there, use an aqua. Increasing, 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 increasing. Where does it appear this graph is increasing? Always. How would I say always mathematically? There you go. So it's increasing from negative infinity all the way to positive infinity. The whole graph is an increasing graph. Yeah.
Wait, but the line straighten out by the
Nope.
time it goes
Nope.
past
It's infinitely close to that line, but we'll never get to it. So think of it this way. Can you ever, so if you take a fraction, can you take a half of any fraction you think of? Like 1 over 100, half of that is 1 over 200. Half of 1 over 200 is 1 over 400, which that's a tiny little fraction. 1 over 800, 1 over 1600, 1 over 32nd hundred. You know, it's getting real close, but it's never going to get there. So if you were to look at it with just your eye and say, yeah, it looks like this is getting to be a straight line, you are correct because it's getting very close to that, but mathematically it's not going to. It's just getting closer and closer and closer. The slope of the line is getting closer and closer and closer to being a slope of 0, but it's not going to get there.
So mathematically, no line can be straight.
On this line, no. All lines can be straight. Straight lines are straight lines, but this is not a straight line. This is the function 2 to the x power. For what values is h of x negative? H of x negative. Will my red graph that now is covered up with my bluish aqua colored lines, will this ever go underneath the x-axis? No. Will it ever be negative? It's never. It will never be negative. Okay? I can plug negative values in on the x direction, but that's not going to give me a negative y value ever. Okay? And let's see. Letter E, what is the range? Didn't ask for the domain on there at all? No domain? Okay. The domain would have been negative infinity to positive infinity if it asked. But the range, where does it appear I am growing from in the vertical direction? I'm climbing my ladder. Climbing my ladder. If I look this way or this way, not up or down, can I see my graph at all? No. Tell me when I can see my graph. Just barely above that line, right? Barely above 0. So now I can see it. So my range is going to go from 0 to infinity. Why is it not going to be exactly at 0? If I'm at exactly 0 and I look down and let's say I don't have any peripheral vision up or down, I can just look directly in a straight pointed line. If I was at x, or if I was at y equals 0, I'm looking down, I don't see my graph. I don't see it crossing. As soon as I move a smidge above it, it's like, oh, there's the graph. What do you think? Doable?
Very good.
Cool. All right. That was pages 67 and 68. Is that correct?
Yes.
Okay. So let's hold off on handing that in. We did it. I want you to be able to use that for tonight. So page 69, and you get to start on this now. You have some time. Page 69, 70. That's for tonight. And this I will check off tomorrow. This will be done for tomorrow, where I will check it off or put a mark. Cool? Oh, and I never changed my calendar, so I don't know what we're doing. Yes, you good? All right. Hit and stop. You.